We've been told that Mars is humanity's next home, that one day we'll build cities on the red planet, farm its soil, and raise children under its pink sky. It's a beautiful dream, but here's the question nobody seems to ask. Can we actually survive there? Or have we been sold a story so compelling that we forgot to check the math? Mars is the fourth planet from the Sun. It's about half the size of Earth. It looks red, dusty, and vaguely familiar, like a desert that stretches to the horizon. And for decades, we've been told that this is where humanity will go when Earth is no longer enough. But the closer you look at Mars, the more the dream starts to crack. Let's start with the air. Mars has an atmosphere, but barely. It's incredibly thin, made almost entirely of carbon dioxide. There's almost no oxygen. You couldn't breathe it. You couldn't even walk outside without a pressurized suit. On Earth, our atmosphere is thick enough to protect us, sustain us, and give us every breath we take. On Mars, the air is so thin that your blood would literally boil if you stood on the surface without protection. Not figuratively, literally. Then there's the temperature. Mars is cold, not just wear a jacket cold. We're talking minus 80 degrees Fahrenheit on a warm day. In some regions, it drops even lower, cold enough to freeze carbon dioxide out of the air. The warmest it ever gets near the equator is roughly the temperature of a cold winter day on Earth. And that lasts for a few hours before the sun sets and the temperature plummets again. But the cold and the thin air, those are problems you could maybe engineer around. Radiation is different. Mars has no global magnetic field. Earth has one. It's the reason we're alive. It deflects cosmic radiation away from the surface. Mars lost its magnetic field billions of years ago. That means the surface is constantly bombarded by harmful cosmic radiation. Long-term exposure is devastating to human health. Every day on the Martian surface, your body absorbs radiation that would take months to accumulate on Earth. You could build underground. You could bury your habitats under meters of Martian soil. But then you're living in tunnels on another planet forever, and that's just survival. What about building a civilization? Who builds the domes? Who brings the construction equipment across millions of miles of space? Who digs through Martian rock and soil to create underground cities? Every bolt, every panel, every piece of machinery would need to be shipped from Earth at enormous cost. Or manufactured on Mars using technology that doesn't exist yet. Water? There's frozen water on Mars. That much we know, but extracting it means sending machines deep into hostile terrain, finding energy sources to melt and purify it, and maintaining those systems in an environment where everything breaks. Every solution creates 10 new problems. And food. Growing crops on Mars would require controlled greenhouses, pressurized, heated, shielded from radiation, supplied with water, energy, and constant maintenance. One system failure and an entire crop dies. On Earth, agriculture works because the planet cooperates. On Mars, every single condition needed for life must be created artificially and maintained without interruption. Here's what doesn't make sense. We're talking about spending trillions of dollars to survive on a frozen, radioactive desert millions of miles away. And yet, urban areas occupy only a small percentage of Earth's land. Vast regions of our own planet remain sparsely populated or completely uninhabited. Deserts that could be solar-powered, oceans that could be farmed, underground spaces that could be developed. We haven't even begun to use the planet we already have. Maybe the biggest challenge isn't finding a new world. Maybe it's learning how to take care of the one we already have. Mars isn't going